Hello! Okay, so for starters, uh, mine opens up in the browser and I just click the rotate button. I'm assuming you'll be able to do the same. Uh, there you go! Some of y'all send me stuff upside down. I deal with it. Okay, let's take a look at this. I just wanted to walk you through an actual word problem using the bearing that's like in the lab manual. So a ship leaves port, sails 15 miles south 40 degrees west, turns, sails another 21 miles north 28 degrees west. How far from port is the zombie shark ship? All right, so start off drawing your diagram. So I started here port, southwest is down quadrant 3. So you can see my arrow going down to the A, at which point the turn. So the thing about this bearing is that it's the angle from the vertical. So you can see my dashed line, there's the 40 right there, and then you can see my dashed line, there's the 28. Over a little on the left here, I've drawn the triangle. Now the 40 is not in the triangle at all, and the 28 is part of angle A, but not the whole part. And you can see what we're solving for is the side opposite angle A. We've got the other two sides, so once we figure out angle A, law cosines, easy peasy. So there's a parallel line rule alternating interior angles like that. So the two dashed vertical lines, those are my north-south lines, so they're parallel. And then that line from A to P, the port, is where that 40 degrees is right there. And you can see on the other side of that line, the other angle is also 40 degrees, which is this angle a little bit to the right of that dashed line where the 28 is. So that angle A in the triangle is 68 degrees. Now you could probably figure it out different ways. You could use right triangle stuff. So there's options, but you have to be able to turn the information you're given into something useful. And on Blackboard, you saw my note, after we do vectors, this is a good one to try with vectors because you'll change these angles differently than by using a triangle. So it's a good one to practice both ways. Once you've got that angle, boom, you just plug it in the formula into calculator. You're done. Easy peasy. But getting it to that point, that's always the hard part. All right, so the other question that's a little bit harder is figuring out what angle they need to turn back. So pause, thinking. So there's a couple of ways of answering that angle, and we're going to focus on using the bearing and turning it into the bearing, and I'm going to do an angle in standard position. Now note that the turn back is not the angle in the triangle. That's a different angle. We're going to use it. So don't get overwhelmed with everything. I'll walk you through. So I redrew my diagram and I just labeled that upper left as angle B. So that's the angle in the triangle. Now because we figured out all three sides, we can figure out that angle. We could figure out the angle on the other one, angle C, but we don't really need it for this. So angle B, you can see I just plugged everything in the formula in the calculator, 42.1206 degrees. So let's think about how we're going to use that to help with the bearing. So my next diagram with the dashed lines down here in my double 28s. So the original 28 degrees, that's from the vertical down to that side of the triangle that I've labeled down here AB with the 21 miles. So that 28 on both sides there, but that 28 is still not the answer. So here is my other diagrams. I've got this 28 degrees where my AB line is, and the side A that we solved for earlier, that's this line here with the arrow. That's where we're going to be turning and going back towards port. So that is angle B in the triangle, and there's angle, the 28 degrees that we started with. So remember, the bearing is from that vertical up to that line. So angle B, we just calculated, added to that 28 we were told earlier, that's the bearing angle. That arrow is going down to the right, so that's the quadrant 4, that's southeast, like that. Since that 70 is from the vertical, which is the 270 angle, to put it in standard position, we would add it there. And then try this part too with the vectors. Sometimes students find it easier with the triangle, other students find it easier with the vectors. It just depends on you, and it makes no difference to me on the test. It just says, what's the answer? And you'll do it however you want to. And again, there might be other ways to figure out these angles. This is how I did it. So you might just try, if you haven't already, just, try it on your own. And then see, don't pay too much attention to my stuff here. See if you can figure it out, then compare it to what I did. If you get the same answer, probably you got it correct. Okay, I'm done with this video.